Good morning, dear students. Welcome to this session on prestressed concrete. Uh, Let us see loss due to creep of concrete in this session. So we have defined what is creep in the unit 1 when we talked about the properties of uh, concrete. Okay. So sustained pre-stress in concrete of a pre-stressed concrete member results in creep of concrete. Okay, so creep reduces stress in steel because the concrete is going to be compressed because of the constant stress acting on concrete. So that is going to cause the compression of concrete, and in turn the steel will be compressed, and that will reduce the stress in steel. uh, the loss due to creep of concrete can be estimated if the magnitude of ultimate creep strain or creep coefficient is known. There are two such methods. So one is ultimate creep strain method, where you can calculate by using the ultimate creep strain value multiplied by the stress in the concrete at the level of steel multiplied by Young's modulus of steel. Okay, and if you want to solve it by creep coefficient method, creep coefficient is nothing but is already being discussed, creep strain by elastic strain ratio. So where the no creep strain value is equal to phi into creep coefficient into the elastic strain. Okay, so that way you can find it out the losses by simplifying these expressions. You will have like creep coefficient multiplied by stress in concrete at the level of steel and modular ratio. Okay, so this is how you can calculate by the way of creep coefficient method, and all these are being explained in class 6 to 5 of your IS code. Just go through the IS code, okay, which we have extensively discussed in the previous sessions. Okay, now let us see an example. A concrete beam of rectangular section 100 mm wide, 300 mm deep is pre-stressed by 5 wires of 7 mm dia located at an eccentricity of 50 mm. Okay, where the B value is 100 and D value is 300. So this will be the eccentricity of 50 mm given 7 wires. Initial stress is 1200. Estimate loss of pre-stress due to creep of concrete using ultimate creep strain method and creep coefficient method. Okay, so this is being changed to 2012 now, not 1980. So the textbook latest versions have to be taken and use the following data. Young's modulus of steel given I value you can calculate, no need of the data. Young's modulus of concrete and cross-sectional area is 300 into 100. And pre-stressing force, there are 5 wires of 7 mm dia. So 5 into cross-sectional area into 1200 is the stress into cross-sectional area of one wire, which is pi d square by 4, which is pi into 7 square by 4 into 5 wires. So this is the force value. Creep coefficient is taken as 1.6, and which is taken from even the IS code also. Okay, which is a table given in 625, class 625. First, you have to find stress in concrete at the level of steel. That means P by A plus P into E into Y by I. So that is the second term, P E Y by I. It's like M by I into Y. So that will be 10.2 Newton per mm square. Okay. And now first method, creep ultimate creep strain method. So ultimate creep strain is 41 into 10 power minus 6 given. Okay, so that you take it given value fc, you have to get it from the calculation, like stress in concrete at the level of steel and Young's modulus of steel, that will be 88 Newton per mm square. When you use creep coefficient method, you have to use phi as creep coefficient. FC again 10.2 stress in concrete at the level of steel, and modular ratio ES by EC, Young's modulus of steel divided by Young's modulus of concrete. So that will be giving you 97.92 Newton per mm square. Okay. Right. A post-tensioned concrete beam of rectangular section 100 mm wide, 300 mm deep is stressed by parabolic cable with the 0 eccentricity at the supports and 50 at the center of span. Okay. The area of cable is this much, and initial stress in the cable is 1200. uh, if the ultimate creep strain is 30 into 10 power minus 6 no, of stress, and modulus of elasticity of steel 210, compute loss of stress in steel only due to creep. Okay, so cross sectional area 100 by 300, you can get it, and pre-stressing force, now stress is there, area is there, so get the force value, I value, and eccentricity. It's a parabolic cable. So stress in concrete at the level of steel at support is just P by A, because 0 eccentricity at the support. I mean, if you just draw the beam, just for the sake of the example. So the cable is like parabola. It is at center, I mean 0 eccentricity at the support, and at center it is 50 mm. That is how you can P by A, and at the center of the span you have to do it by P by A plus again P into E into Y. Both will be same because the level of steel is same as Y by I, so that is 10.7. So average stress you have to get it because the cable is parabolic. So P by A, that means 8 plus 2/3 of difference of support section and center span section values. So always remember, if you have a parabolic cable, go for average stress, so it is 9.8, and loss of stress due to creep, so it is like creep coefficient, ultimate creep strain value given to you, ultimate creep strain value, stress at the level of steel, and Young's modulus of steel, that is this value. So this is how you can get it if the cable is straight and if the cable is parabolic. So only thing you need is either ultimate creep strain value or creep coefficient value. So there are two such methods which you can calculate the loss of stress due to creep. Okay. So these things you can even follow the IS code that I'll show you wherever it is available. So go for 625, open your IS codes. So see 625, how it is being given. Okay. So this is 625. It talks about creep. So if you want creep coefficient value, okay, because your the one of the methods of solving for loss of pre-stress is creep coefficient method. It is simply multiplying creep coefficient phi, creep coefficient value. I'll just show you the formula. Right. So multiply this creep coefficient phi value with stress in concrete at the level of steel and modular ratio. So to get this value, you have the IS code procedure also, okay, where this is creep coefficient. So phi will be calculated by simply phi naught into beta, okay. So how you get phi naught is again phi RH beta FCM and beta T naught, and whereas beta value will be calculated from class 6252, which is here, okay. So which is t at what age you are calculating creep, because it is time dependent. Maybe after 1 year, after 10 years, you have to substitute t in number of days. T naught again, the number of days at transfer, in initial time of loading, pre-stress transfer after 7 days or whatever it is. So T naught will be roughly 7 days, okay. And beta h, you have to get it from the formula again. So this beta can be calculated from this 6252 again. So again, the different terms in the phi naught to get it. Phi RH will be calculated by these formulas, either depending on the FCK value. If it is less than 45, use this one. If it is more than 45, use this one, okay. And all this beta FCM is to get it, no, it is the factor which accommodates effect of strength, and beta T naught which accommodates the concrete age, okay. So beta FCM and beta T naught in this formula can be evaluated like that, and phi RH from this, okay. So that is from formula. Say if you don't have all these data, you can straight away read it from this table, okay. So if you say humidity is 80% and the load at transfer is 7 days, okay, humidity is 80%, and your notional size, which is 2 times AC by U, is like 150. You can straight away take this 2.4 as your value of phi naught value, like creep coefficient value, okay. So like this, you can use the IS code also for this purpose of calculating creep coefficient value, okay. Right, thank you. Practice.